The first web server came online in 1990 at CERN, which is the European Organization for Nuclear Research. The potential of the web was realized soon after to share all kinds of human knowledge, facilitate social interaction, provide entertainment, and connect people from all over the world. Websites are now critical to companies and organizations, no longer viewed as optional, and these websites are often created and maintained by a team of developers. Social media management, content strategy, user experience, user interface design, search engine optimization, email marketing, and many other areas of expertise are important for supporting website construction and maintenance well beyond just coding. In this course, I'll introduce you to the world of web design and development. Then we'll take a peek at the 3 technologies that power the front end of websites, including HTML, CSS, and JavaScript. We'll write a little code so that you can see how that feels and see if you enjoy that work. Finally, we'll look at the no-code world. This is an emerging field where there are many technologies available for developing websites without knowing how to code. I'm Jen Kramer, and I've been building websites for over 20 years. You can find your own place in this world if you want to join us. So if you're ready, let's get started learning about website design and development. 2 words that appear often in the web design and development space are clients and servers. Let's start with servers. This is a word referring to either software or hardware that serves up files or websites to computers which request them. Sometimes the server software runs on the server hardware, and sometimes the server software is located elsewhere. It's very confusing, so let's clarify. You may also have heard of someone talking about the server room. It's an over-air-conditioned space with scores of computers on racks, wires everywhere, and some poor server maintenance person staying warm in a hoodie, keeping it all running. In this case, this is the server as hardware, a very powerful computer that's designed to handle many simultaneous connections and serve up files as requested. But what causes those files to be served up? That's the server software that executes those commands. There are different types of server software, like database servers, cloud computing servers, file servers, and web server software. Web server software is what we're interested in, and there's several makers of this software. Some of it is free and open source, like Apache or Nginx. Some are proprietary from big companies like Oracle, Microsoft, and IBM. When web server software runs on web server hardware, and that system is maintained by a company who will sell you some space on it, that is referred to as a web host or hosting. When you build websites, you'll need to get a web host, and we'll talk more about that in a later segment. Now let's move on to clients. You may think of a client as the person who hires you to do some type of job. That's true, but it's not what we mean here. A client is the device that talks to the web server to get web pages to display. On a typical Mac or PC computer, the client is the web browser like Firefox, Chrome, Safari, or Edge. Your phone or tablet may have different choices for web browsers, but they still function the same way. The client does not have to be a typical web browser. For example, if you've used Netflix, Hulu, Disney+, or similar services on your TV, you're working with a client as well. These clients connect to the appropriate server to send you TV shows and movies on demand. Regardless of what the client is, its job is to request materials from the server and display them on the client's screen. You enter a web address in the browser or you choose a movie on the application. That request is sent over the internet to the appropriate server. The server gathers code, images, video, audio, or whatever else is needed to render the display, and it sends it all back to the client computer. The client receives those assets and follows the code to assemble the pieces appropriately to fill your request. Remember, the web client is the device in front of you, which runs some type of software that allows you to connect to a desired web server. The web server will send you the pages you request. It all happens in the blink of an eye. When drawing diagrams of networking systems, the internet is always portrayed as a cloud. Why is that? Because there are so many ways in and out of the system. The internet was designed to be decentralized with many different routes to the same information. When your files are in the cloud, that means they are stored somewhere out there on a server someplace. A great example of cloud services is email. 20 years ago, email was frequently stored on the computer in front of you. You used a program like Outlook or Eudora, which pulled the email from the server and onto your computer where you could read it or store it. However, there were serious downsides to this model. What happened when you wanted to read your email someplace other than that specific computer? What happened if the hard drive broke? Or what happened if you got a new computer? Somehow you had to figure out how to back up your email or transfer it to other computers. Today, most people have a cloud-based email like Gmail, Yahoo Mail, or Outlook 365, which leaves your email in the cloud. These services back up your email for you, plus they allow you to have access to your email from any device and keep that email in sync. With a quick refresh, your email looks the same no matter where you look at it. Other cloud-based technologies you might use every day include remote file storage locations like Dropbox, Box, Google Drive, iCloud, or OneDrive. These services have become critical for sharing files with others and storing our own files so that they're accessible on all of our devices. Notably, cloud apps may be used offline. When the computer reconnects to the internet, the data is synced with the cloud. Finally, cloud apps may use a web browser to function, but they may also use some other application. For example, Dropbox may be accessed through a website, or it may run through an application on your computer. You can still use Dropbox through the application if your computer is not on the internet, but your files will not synchronize. Once you reconnect to the internet, then the files synchronize. A web app is an application that runs inside of a web browser. eBay, for example, is a web app. You may browse, buy, and sell all kinds of products on eBay, but only if you're connected to the internet, and only if you're inside of a web browser. The internet connection must be active in order to use a web app. There is no offline mode. These are only some of the differences between cloud apps and web apps. There are others, but they involve system architecture, which is beyond the scope of this course. You may find other resources about cloud apps and web apps in the library. Native apps and web apps are easily confused. If you're a developer, the differences are straightforward, but if you're a consumer, differences are more difficult to discern. Both native and web apps run on phones and tablets. A native app is an app designed for a specific operating system, like iOS or Android. Native apps are often coded using programming languages like C++, Java, or Swift, among many other choices. These languages require compiling before they can run on a given device. Each platform provides their own interface elements and development tools for creating native apps. Compilers, interface elements, development tools, and debugging mechanisms are often distributed in the form of a software development kit, or SDK. Because there's a large programming overhead to native apps, they tend to be more expensive to build. Once built, native apps are placed in the appropriate location for downloading, often the App Store or Google Play. There may be requirements for having your app listed in these locations. Alternatively, you can ask website visitors to download your native app. In any case, site visitors must download and install the app on their device to use it. Native apps may run offline, not requiring a constant connection to the internet. For example, consider Gmail. If you're using the Gmail website for writing and sending email, it gets very upset if you're not connected to the internet while you're writing. Indeed, it may lose part of your email. However, if you're using the Gmail app on a phone or a tablet, You may write an email when the phone is not connected to the internet, then send the email when you are back in touch. Web apps are very different from native apps, although their user interface may often look or feel the same. A web app always runs through a web browser. There's nothing to download to use it. Simply visit the website on your device using your standard web browser, and you'll be able to access the web app. The Gmail website is an example of a web app. These days, web apps are often built with JavaScript, HTML, and CSS, which we'll discuss in more detail later in the course. Web apps may talk to databases located on web servers. In this case, there may be some server-side programming languages involved, like PHP, Python, Ruby, or more JavaScript. No compiling is needed for web apps to run, and there's no app store for web apps. Each methodology has its own advantages and disadvantages. Web apps are cheaper to build, cheap to maintain and update, and accessible to all with a web browser. However, web apps don't work offline. Furthermore, since web apps aren't uploaded to an app store, no one checks their work for security issues. Anyone can build a web app, and anyone does. For native apps, they may run offline, which may be a major advantage. Because they use a common interface element with other native apps on that operating system, they may feel intuitive and familiar to users. However, native apps are very expensive to build, maintain, and update, and apps must generally be approved by the App Store, a time-consuming and expensive process itself. What type of work is best for you? If you like compiled programming, a standard interface, and want to work for larger companies, learning native app programming may be for you. If you prefer working with companies of all sizes, working with the web, or building applications quickly, you may be a better fit for web app work.